Okay guys, I'm still learning derivatives and this will be the last topic of the derivatives. Let's review that. So we have implicit differentiation. That is our topic, implicit differentiation. Let's see the notes, and I'm gonna try to do all of them by myself. I want to read if y is an implicit, if implicit differentiation, okay, if y is an explicit function of x, okay, then it is a clearly defined function. If y is an explicit function, okay, for example, y equals to cosine of x. That is explicit, yes, because, okay, I get it, what does it mean? However, we can also define functions implicitly. The equation is y squared plus 2xy minus 5x squared. Defines y as function of x. Suppose we wanted we want to find the y over dx for the y defined by this function. Okay, let's search about it. I really want to understand it very well. What is implicit differentiation? Explain me simply, and why we use why or when, oh my gosh, when we use it. Okay, implicit is a trick when you cannot want or you don't want to solve y first. The simple explanation, normally your differentiate function like y equals to x squared, it is explicit. You do the y left side to x right side, easy. But what about x squared plus y squared equals to 25, a circle? Okay, you can solve for y equals to, yes, but it is a messy and you get two separate equations, true. So okay, let's try this one. Is if we get like, normally we know that y equals to x squared, so it is so easy, we can understand that is explicit. What about x squared plus y squared equals to 25? When we find y squared equals to 25 over x squared, so we will have two roots. The first one is positive 25 over minus x squared, and the second one is negative 21 minus x squared. So that's not true. With implicit differentiation, you don't solve for y. Instead, you differentiate both sides term by term, and every time you touch a y, you slap a dy over dx on it, because y is a function of x even if you don't know what it is. Then you just use algebra to solve for dy over dx. Okay, when we see dy over dx, we will mark it, we will just put this one for the y. Dy over dx will be y. So my teacher has written this to the PDF. All right, and for example, for x squared plus y squared, x squared plus y squared equals to what? 25. Differentiate this one and differentiate this one. Okay, we understand what it is. Okay, all right, I get it. I got the first slide. Example, if y cubic plus, let's do this. By the way, my teacher has written the solutions here, but now I don't want to review it. I just want to do them by myself, then review it, because I think it would be really helpful. Let me do this like this, and so basically trying to find we are basically trying to find the derivative of the functions, and whenever we see y, we will plug dy over dx. Let's say not style. I think grid or dot. Okay, let's try grid because it's easier. But anyways, so y squared plus 2xy minus 5x squared equals to 0, and we need to find dy over dx. The derivative of the y to the power of 3 will be 3y squared plus 3y squared times dy over dx, isn't it? Plus 2xy. What is the derivative of 2xy? That is a product rule. So I just wanna do this like this. The derivative of x, let's do this 2 times x times y. Okay, 2 times xy, like this. Okay, the derivative of x will be 2y plus the derivative of x will be x times dy over dx minus 10x will be 0. I hope it's right, but if it's not a big deal. Okay, so simplify it. 3y squared plus times dy over dx plus 2y plus 2x times dy over dx minus 10x will be 0. Dy over dx 3y squared, so like this. Okay, 3y squared, they're together and these are together. Okay, dy over dx will be what? 3y squared plus 2x plus 2y minus 10x will be 0. So let's do this. How to find dy over dx? Dy over dx will be 2y minus 10x over 3y squared plus 2x. I hope it's right. And let's see if it's right or not. My teacher has written. That says a little bit heavy for my tablet. Okay, so that's why I'm gonna do this like this. Why it's working really slow? I don't know. So let's check it. Okay, not like this, but like what? Like this. So 3y squared dy over dx plus 2x. What is the derivative? 2y plus 2x dy over dx minus 10x. That's true. And dy over dx 3y squared plus 2x plus 2y minus 10x. So dy over dx will be 10x. What? Yeah, oh my gosh. Yeah. Oh my gosh. That's simple mistake, but that will be 10x minus 2y over 3y squared plus 2x. Okay, that is true. Good job. That was our first problem. What about the second one? Okay, if x squared minus sine of y plus xy equals to 0, and find dy over dx. Alright, that will be 2x 2x minus a derivative of sin y will be sine will be cosine y, and cosine dy over dx plus derivative of x will be y plus derivative of y will be x times dy over dx. and common factor dy over dx. Wait a second. So dy over dx, x minus what? Cosine y will be, I think. Cosine y or what? Sine will be cosine y. Cosine y times dy over dx. Cosine y, I think. And that this will be what? Negative 2x minus y. So dy over dx. I think it's not true, but anyways. Negative 2x plus y over x minus cosine y. I don't know that exactly, really. But let's see. Product, okay, 2x minus cosine y times, yes, dy over dx plus y plus x times dy over dx equals 0. dy over dx will be x minus cosine y. Yes, that's true. dy over dx will be negative. Yes, that's true. Amazing. All right, let's try to do the third one. Let me see. So we have so many, 8 problems, and what is the third one? So the point 2p is 2m, where m is less than 0, lies on the curve 2x squared y, okay, 2x squared y plus 3y squared equals to 16. So we need to find the value of m and gradient of the normal to the tangent at point m. Okay, firstly, we need to solve it and then I will check them. So firstly, let's solve it because we cannot do anything. So I think that the first is to find the derivatives and simplify it. That will be 4x, no, it's the product rule, okay. 2 times, let's say. That will be 2x, yes. That will be 2xy plus x squared times dy over dx plus, what is the 3 times 2? 6 y times dy over dx equals to 16. So 4xy plus 2x squared times dy over dx plus 6y times dy over dx will be 16. Common factor is what? Dy over dx. Okay, dy over dx. 2x squared plus 6y equals to 16 minus 4x y. Dy over dx will be 16 minus 4xy, 2x squared plus 6y. And we have this equation, okay, and I don't know if it's true or not, but anyways, we will start again if it's not true. Let's plug the points. Point P, that will be 2m. So we need to plug 16 minus 4 times x is 2 times m over 2 times 4 plus 6m. That will be what? Dy over dx. So 16 minus 8m over 8 plus 6m will be dy. Is dy m or not? M over 2 I don't know that exactly, but I think it's really wrong. So I think that I'm doing it wrong, but let's try this again. What is my mistake, guys? What is my mistake? Delete. There must be something wrong here. Again, delete and delete. So 2x squared y plus 3y squared equals 6. Okay. 2 times, what is the derivative of this one? dy over dx plus 3 times 6y times dy over dx. I think it's true. Will be 16. So 4xy plus 2x squared times dy over dx plus 6y times dy over dx will be 16, and I'm doing the same thing, I know that, but anyways, 2x squared plus 6y, 16 minus 4xy, dy over dx will be 16 minus 4xy over 2x squared plus 6y. So they're all true, okay. So m will be less than this one. Okay, m will be less than 0. So it means that we will have something like 4 roots or what? I don't know that exactly. Okay, I know that's true, okay. We have the points, but if we plug them, that will be 16. Yes? Okay. Oh my gosh, I was missing something. So I need to find them, yes. And that's true. So we need to plug them. But the wrong thing that I did was, that was a terrible mistake, by the way. I put dy, I put m instead of dy and x instead of dx, but actually if we use the original function, oh my gosh, that's so bad mistake. 3y squared equals to 16, and I need to remember something, that if we have points, we need to put that points into the original function. So that is our points. 2 times 2 squared will be 4 times m plus 3 m squared equals to 16, 8m plus 3m squared 16. Oh my gosh, I don't want to do discriminant, but I think we will. 8m will negative 16. So let's try to find it. 1 m 3m 8 negative 2 maybe 24 no 4 negative 4 12 minus 4, yeah, that will be. So our roots are m minus 4 times 3m, no, sorry, I did a mistake. So 12 minus negative 4, okay, m plus 4 times 3m minus 4 will be 0. m1 equals to negative 4, m2 equals to 4 minus 3, and that is the thing that where m is less than 0. So less than 0 is this one. So our m is negative 4. All right, and that's it. Is that gradient of normal at a point? Gradient is this one. If we are being asked to find a gradient, it means that we need to find a derivative Okay, well, the value of m, that must be easy for me to find the first one, but I don't know why I didn't. So let's check it. Exercise 3. Okay, my teacher did discriminant. That is a little bit long way, but my version is short, but it doesn't matter. And the other one is what? He extra, I remember that he extra found m tangential or m normal, if I'm not mistaken. Find the gradient to the normal. Oh my gosh. Okay, well, he did it. Okay. So we found that the first one. We found first one. What about this one? And because I need to find m tangential, but I didn't because I didn't read question very well. Okay, that is our negative 4xy. Oh my gosh, I forgot. Oh my gosh, I made a terrible mistake here. Because you know why? Okay. I need to do this again because I know that if I don't, I will not learn it. So we need to find the derivative of the functions, but I forgot to find derivative of 16 and it will be 0. Yes. So dy over dx will be what? 2x squared plus 6y equals to negative 4xy, and dy over dx will be negative 4x over 2x squared plus 6y. Alright, 2x squared plus 6y. Alright, we have this one. And let's learn it. Our points was p equals to m, and our m is negative 4. We found here. Yes, so it is p to negative 4, and when we plug this dy over dx to negative 4, it will be what? Negative 4 times 2 over 2 times 2 squared plus 6 times negative 4. It will be negative 8 over 8 plus negative 24. It will be negative what? That will be what? Again, oh, there's something again I did mistake, and oh my gosh, this one. Okay. Okay. Negative 4 xy over 8 minus 6y. Yes, it's 6y. Yes, negative 24. It will be negative 16. 2 times 4 times 4, 6, 32. It will be negative 2. Okay. So dy over dx is what? Negative 2. It means that our slope is negative 2. That is what? M tangential. Alright. Other one, negative 1 over 2 will be. But it is really, the way I did it was really bad and complicated. That's why I'm gonna do this again. Okay, delete and delete. Okay, not this one, but delete all of them. What is our question? Firstly, what is the value of m? If we want to find the value of m, it means that we need to plug the numbers. So our question says that p is 2m and m is less than 0, so that's why 2 times 4 let's write this. 2x squared y plus 3y squared equals to 16, and we have p2 endpoints. 2 times 4 times m plus 3m squared equals to 16. 8m plus 3m squared equals to 16. 3m squared plus 8m minus 16, it will be 0. 3mm, so that was like m, 3m, and 4, negative 4, yes, 12 minus 8. Okay, m plus 4 times 3m minus 4. Let's do them like this. Okay, so it will be what? It will be 0. m1 is negative 4. m2 is this one, but we will plug this one because m must be less than 0. So m will be negative 4. Okay. I will be negative 4. What about the second one? Okay, be careful. Find the gradient of the normal to the tangent at point P. Gradient of a normal to the tangent. Okay, let's find the gradient. First one, we need to find gradient, then normal line, and tangential line. Tangential. Okay, first one, if we want to find the gradient, it will be the derivatives. 2x squared times y plus 3y squared equals to 16. So what is the derivative of this function? It will be what? 2 times its product rule. 2x times y plus no, yes, 2 times, because I get confused. 2x times y plus x squared times dy over dx plus 6y times dy over dx will be what? Find the derivatives of both sides. Will be 0. 4xy, 2x squared dy dx plus 6y times dy over dx will be 0. dy over dx is the common factor, this one. 2, let's find this, like negative 4 xy times 2x squared plus 6y. Okay, this is our dy over dx, but by the way, okay, let's delete this one because I forgot not delete. Alright, so okay, dy over dx is negative 4xy times, that is what? That is our gradient. What is gradient? That is our y equals to mx plus b. Okay, that is our m. Imagine like this. So it is normal line, alright? Then it is normal line. That is normal line. If we plug 2m here, we will get our normal line. Yes. So if we plug 2m and we found that our m is what? Negative 4. That will be to -4. We will get our normal line. So negative let's write that m will be, or dy over dx, doesn't matter, but m, no, we have m here, so let's say that is our k. Okay, k will be what? Negative 4 times x times negative 4 over okay, over what? Okay, over 2x squared, 2 times 4 plus 6 times negative 4 will be negative 8 times negative 4. 32 over what? 32 over 8 plus negative 16, that will be negative 2. So imagine that, not that will be, normal formula is m1 times m2 equals to negative 1, but now it is different because so, or m normal times m tangential will be negative 1, but here we substitute it with k, okay, because we have m here, so I don't want to confuse, so k normal times k tangent will be negative 1. So k normal is what? Negative 2 times k tangential will be negative 1, so our k will be 1 over 2. So it is our k tangential. We found that answer will be m is negative 4, k normal is negative 1, no, sorry, negative 2, k tangential 1 over 2, and gradient, okay, we found it. So that's it, that's our function. I think it's true, but I have a mistake here, because why? No, do I have? No, I don't have. M normal is 1 over 2. Okay, that's my mistake. That must be m tangential. Why it is m tangential, I don't know, but I thought that it must be m normal, but I found that m normal is negative 2 and m tangential is 1 over 2, but that is not like this here. Okay, why? Let's try to find it. So 2x squared y plus dx 3y squared equals to 16. What question asks? Reset. Calculate the point P where that is 2m, where m is less than the 0, lies on the curve. Why I cannot write? Curve 2x squared y plus 3y squared equals to 16. So A asks find the value of m, and B asks find the gradient of the normal to the tangent at the point P. Find the value of, okay, m is -4. Yes, find the gradient at, so tangent why is this tangential? I forgot it maybe, but let me ask. Okay. Alright, dy over dx, the derivative always, oh my gosh, yes. So if you want to find the k, that is tangent line, but it always is tangent line to the normal is a perpendicular to the tangent. So very issue. Stuff that will be incorrect, but if you're just naming the whole person finding the normal derivative first. Okay, the derivative is okay, that's my bad. Derivative is always m, and m is the tangential, so I just named them wrong. So it must be k tangential, and it will be k normal, k tan, k nor. Okay, we did it. That is because I didn't do math for 2 or 3 days. I forgot it. Okay, that's my bad. But we spent so much time on this question. Okay, let's try to do other one. Example 4. Find the equation of the tangent and the normal to the curve. It's a good example because I made mistake in exercise 3, but I don't want to do this right now. So it will be what? X squared minus xy plus 2y squared equals to 5. At the point this one. Okay, what we are gonna do firstly, we will do what? In this point, if you want to find the m normal and m tangent at this point. So find the derivative 2x minus derivative of x will be y, derivative of this one will be what? X times dy over dx. Okay, plus 2 4y times dy over dx will be what? We need to find the derivative of both sides. That was my mistake, but I won't do this again. So it will be what? 0. And simplify it. 0. Common one is this one. Let's find it like this. Okay, let me check it. That will be what? Okay, that's true. What about this one? This one is also true. Good. So it is what? That is our M tangential, okay? That is our M tangential. If we plug this one, we will find M tangential. So M tangential will be so we don't need to solve it because it will be what? 0. If our M tangential is 0, it means that M normal doesn't exist. Okay. Let me see. Yes. True. Okay, let's do exercise 5. Exercise 5 will be x squared plus y squared minus 6x minus 8y will be 0, where the gradient is 0. So dy over dx will be 0. That is our gradient and it will be 0. So 2x plus 2y times dy over dx minus 6x minus 8 times 8 times 8y or 8y times dy over dx will be 0. So dy over dx will be what? Will be what? 6x minus... Oh, wait a second. Oh my gosh, sorry. I made a mistake here because 2x plus 2y times dy over dx minus the gradient of this, derivative of this one will be 6 minus the derivative of this one will be what? 8, not 8 by the way, that'll be, oh my gosh, okay, I get confused because I'm too fast. Okay, 2x plus 2y times dy over dx minus, what is the derivative of this one? 6 minus 8y will be what? 8 times, I think, dy over dx, but it's not because 8 times what? Derivative of y will be 0. I think it will be 0. I don't know. I hope it's right. 2x plus 2y times dy dx will be negative 14. That will be 14. So dy over dx will be what? 14 minus 2x over 2y. And it will be 0, so that will be also 0, so x will be 7. What about y? If x is 7, y will be 94 plus y squared minus 8y will be 0. Y squared minus 8y plus 7 will be 0. y1 plus y2 is 8, and y1 times y2 7, that will be 1 and 7. So our coordinates are like, I hope it's right, x is 7 7 and 7 1. I don't know, is that true? If I don't make any mistake. 5, what about 5? Okay, it's wrong. Why it's wrong? Let's analyze it. X squared, so 2x plus 2 times dy over dx minus, okay, 8. When we see y, okay, I found the derivative of the y, but that's true, it's 0, but I need to plug dy over dx instead of it. Okay, dy over dx whenever I see that y, dy over dx will be 0. So it changed the whole equation. That was my mistake. Okay, let's try to solve it as quick as possible, because I'm learning and I make so many mistakes here. Sorry. Okay. Is that true? Yes, I can made a mistake. So good. Are you fucking kidding me? Okay, I made a mistake here again. Why I make so many mistakes? Okay, oh my gosh, I'm really tired of making mistakes. X squared plus y squared, 6x minus 8y, isn't it? Isn't it? This is the original x plus y squared minus 6x minus, okay, 9 plus y squared minus 18 minus 8y 0. Y squared 8y minus what? Minus 9. That's really 9. Minus 9. It must be minus 1, isn't it? Yes. Y1 plus y2 will be 8. Okay. Y1 times y2 will be what? Negative 9. Y1 by 2. That will be what? 9. Negative 1. Okay. 3. Negative 1. And 3, 9. That will be our coordinates, hopefully. 3, 9. 3, negative 1. Okay. That's negative, by the way. Alright. Thanks to God. we have what? We have 2 more problems. Or no, so many questions. 3 more. Okay, we don't have 6. All right. What about example? But we had example 6 here. Yes, I remember this. So let's write 10x squared plus 5x cubic y to the power 4 e to the power of y plus 6 will be x cubic. Alright, we need to find dy over dx here again. Dy over dx. So 10x squared will be 20x plus 5 times 3x to the power of plus 1 plus x to the power 4y cubic times dy over dx. What about e to the power of y? It will be e to the power of y times dy over dx plus 0 will be 3x squared. Oh my gosh, it is complicated one. Actually, it is really complicated, and I just wanna leave it and continue with example 7. Equation normal to the curve. Okay, we have the similar and same tasks, and I don't want to make mistakes because we have made so many questions and I've made so many mistakes. -5, 2 are our points, so I hope it's right. Yes, negative. And find the equation. If we say equation, okay, that is our m normal line. So what is our original function? Okay, how to find if that is mx plus b, we have points -5 and 2. Okay, let's find it. Y equals to m times x plus b. 2 equals to -70 minus 9 plus b. B equals to what? 9, 18 plus this one. Okay, we cannot divide it. So it will be 14x plus this one, or we can write this like this. Is that true? Let's see. 4, 7, 7, 7. Yes, that's true. And let's do the example 8, and we will go back to 6. Find the equation. Okay, equation. Find equation of tangent to the curve with the point in this point. Okay, 4x squared minus 3xy minus y squared will be 25 at 2, negative 3. Okay, what about 8? Okay. Alright, that's true. So what about this one? What about 5? 5? Yes, this one. Let's try to do this one. Let's do 5 too. Okay. Um, Is that true? In 6. 3x squared. Yes, that's true. Okay, I got really tired. So that's all. That was 8 exercises, but really time consuming, and I really struggled a lot, but I learned it. So good. And next lesson we will learn integrals. So that's it. Have a nice day.